Hello, my name is Casey Shivler and I'm doing a reassessment video on the charge distribution standard. I have chosen the following problem. A thin plastic spherical shell of radius 5 centimeters has a uniformly distributed charge of negative 25 nanocoulombs on its outer surface. A concentric thin plastic sphere shell of radius 8 centimeters has a uniformly distributed charge of plus 64 nanocoulombs on its outer surface. Find the magnitude and direction of the electric field at distances of 3 centimeters, 7 centimeters, and 10 centimeters from the center. Alrighty, well, first of all, I drew the figure out up here for you. It asked me to find the magnitude and direction of the electric field at 3 centimeters first. However, I know that the electric field inside of the shell is 0, and outside of the shell is 1 over 4 pi epsilon naught q over r squared. But at the location of 3 centimeters, it's both inside the 5 centimeter shell and 8 centimeter shell. So that gives me a net electric field of 0. Then goes on to ask me to find the electric field 7 centimeters outside of these shells. When looking at this problem, I see that the electric field due to the 5 centimeter shell at 7 centimeters away will in fact have a value of, well, I can use the equation 1 over 4 pi epsilon naught q over r squared. So I know q is equal to negative 25 nanocoulombs. 1 over 4 pi epsilon naught is equal to 9 times 10 to the 9th, and r is equal to 0.07 meters, which is converted from 7 centimeters. So then I plug it in and I get E equals 9 times 10 to the 9th times q over r squared equals 4.6 times 10 to the 4th newtons per coulomb, which is my electric field. In the case of the larger cell, the location is still within its boundaries, so we would just add our previous value to 0, because technically E net is equal to the electric field of the smaller shell plus the larger shell. So 0 plus 4.6 times 10 to the 4th newton coulombs is still 4.6 times 10 to the negative 4. So therefore, that's the same. It then goes on to ask, what is the electric field 7 centimeters away? Or I'm sorry, 10 centimeters away from both of the shells. What I did is I solved for the electric field for both. Due to the inner shell having a negative charge, our first electric field for the inner shell right here is going to have a charge of an electric field of negative 225 or 22,500, and the electric field of the outer shell, which is pretty much double that, is going to have a magnitude of 57,600. Both of those will add up to give me a net electric field of 35,100 newtons per coulomb. Forgot to write that on the board. It asks the direction. Well, as you can see, due to the negative charge, the charge of the inner sphere, or the electric field of the inner sphere, is going to point towards the center, while the positive charges on the outside result in an electric field pointing out due to the positive charges. However, I concluded that due to the electric field of the outer shell being twice as large as the electric field of the inside of the shell, I concluded that the net electric field would point out, just because the magnitude is so large. And that concludes my problem. Thank you.